Hi, this is 1.6. This is our little lecture overview for this section. And this section deals with absolute value equations and inequalities. Okay. First is the little cliff notes here for the equations. You basically have two cases. If you have the absolute value of A equals B, now A and B are just expressions or numbers or something that matter. But if B is positive, then it's just a matter of setting A equal to plus or minus to B. Because what absolute value of A means is the distance A is from 0. So basically what this is basically saying is the distance A is from 0 is B units. Well, the only way that's going to happen is if A is where B is at, hence A equals B, or A is where negative B is at. Okay, so that's why it's plus or minus B. Now, on this one right here on the inequalities, well, first of all, in case 2, the absolute value of A equals B, there is no solution when B is negative because you can't say A is a negative 2 units, for example, from 0. So when that's a negative 2 or negative 5, there is no solution. Okay, like I said, we talk about this a lot more in class, or you need to come to class. Inequalities, there's actually 4 cases. The first 2 cases are the most common. The last 2 cases are what I call the trick cases, because a lot of people get so involved in the case 1 and case 2, whether it's an and or an or, they kind of forget these last 2 cases. And when they come up, most students usually miss them because they'll treat them like the other 2 cases. So when you're looking at this, you might want to write these down again if you haven't done it in class, and really pay attention. Now, I did one of those cases down here in my example 3 down here to show you what's going on. But what this is saying is the absolute value of A is greater than B when A is on the left side of B or A is on the right side of B, because A has to be farther from 0 than B is. That's because that's what that's saying. The absolute value of A is greater than B, basically saying A is farther away. So that means A is on the left or A is on the right of these 2 numbers. Well, when you say it's on the left of negative B, that's the same thing as saying this. And when you say A is on the right side of B, that's the same thing as saying that. So some people just memorize this, but the reason it's true is because of this graph right here. So, and again, that's when B is positive. B has to be positive for this to work. And when B is positive on this next one, when the absolute value of A is less than B, that implies A is between negative B and positive B. So, and a lot of people write it this way: A is greater than negative B and A is less than positive B. So I don't particularly like this method, but I like this method better because of the way I explain it why this is true. Okay, if absolute value of A is less than B, that means A is somewhere between negative B and B because it's closer to 0 than B is. And so that means A is on the right side of negative B because it's got to be closer to 0, or A has to be on the left side of positive B because it has to be closer to 0. So A is in between those 2 numbers. That's what this is saying right here. A is between the negative B and B, so you write it this way. Then case 3 in case 4 is trying to trick you into thinking that if you look at case 3, it looks like it's very similar to case 1. The big difference is this one's B is positive and this one B is negative. Well, when you have the absolute value of A greater than a negative number, well, that's always going to happen. Okay, there's no semantics here. There's no graph to consider because the distance is always greater than a negative number. So that's why it's always all real numbers. Now, 9 times out of 10, that's going to be a positive number on this side. So it's always going to be case 1. But then there's that 1 chance out of 10 that that number is negative, and you got to keep in mind when that's negative, that's something special, and that's when it's all real numbers. So you don't go through the same old routine. Case 4 is when the number is negative, but when it's less than. And in this case, there's no solution because distance is never greater, actually should say distance is never less than. Sometimes I write these things real fast before I do the videos, and I write it wrong sometimes. So distance is never less than a negative number. So that's what that one means. And but anyway, I gave you 3 examples. The absolute value of x plus 2 is greater than 6. So what this basically means, here's 0, and x plus 2 is greater than 6. That means 6 is 6 units from 0 and negative 6. So if this is your A, so x plus 2 is over here, and x plus 2 is over there. So that's why it's saying x plus 2 is less than negative 6, A is less than negative B, or x plus 2 is greater than positive 6. A is greater than B. I know some of you guys are sitting there thinking, well, I just memorized the way you do it. If you just think of the graph, you don't have to memorize it but one time. That's it, just because you understand the concept. So the distance is less than -6, and the distance is greater than +6, because it's got to be the left or the right of these two numbers, because it's got to be farther away, because that's what greater means. It's farther away. It's bigger. So, and then you just solve each one of these. So you solve this one, it's x is less than -8, or x is greater than 4. Subtract 2. So you put that in interval notation, it's -infinity to -8, union 4 to infinity. 4 to infinity means bigger than 4. -infinity to -8 means less than -8. So now this one is the case 2. The absolute value of 3x minus 1 is less than or equal to 14. So if you look at the number line, here's 0, and 14 is over here, and -14 is over here. And 3x minus 1 is less than 14 units away, so it's somewhere between these. So 3x minus 1 is somewhere between -14 and 14, so it's in between. So 3x minus 1 is between -14 and +14. It actually says less than or equal to, so we need to put a bar underneath those. So then we add 1 to everything. So I'm trying to isolate the x is what I'm trying to do. So it's a -13 less than or equal to 3x less than or equal to 15, because I'm adding 1 to everything. And then what do you think? Divide by 3 to get to isolate the x. So divide by 3. So it's a -13 over 3 less than or equal to x less than or equal to 15 divided by 3 is 5. So x is in between the -13 thirds and 5. But in these brackets, because we include that number, so basically what this is, you got to understand what this is. It's saying any number between that interval, including the endpoints, satisfies this example. So if you put a number like 7 in there, you don't even need to test 7, because you know 7 won't work. Because since 7 doesn't fall within that interval, it can't satisfy that inequality. But on the other hand, 2 is on that interval, so 2 should work without even having to check it. Now you might want to check it just to see if you're right or wrong. So that's one good thing about these types of problems is you can do a side thing and put a number, look at your interval, take a number out of your interval, put it back in the original problem, see if it works. And if it doesn't, you did it wrong. Okay? And on the same token is if you take a number outside that interval and it happens to work, then you know you're wrong as well. So these things are quite easy, maybe not to check, but just to make you feel good whether you think you got it right or wrong or not. So in example 3, this one's easy because the absolute value of 5x is greater than -10. B is -10. Now, it's very tempting to do example 3 exactly the way we did example 1 by taking 5x greater than -10 and 5x is less than or equal to +10 and do it that way, okay? Because it's very mechanical. People try to do this, but very mechanical. Sometimes you got to think. This is that 1 chance out of 10 that you might get a problem at that. So anytime you get a negative number on this side, you got to think of that special. So this one actually is everything works, because since distance is always greater than negative number, everything is going to work. So, I mean, if you put 2 in, you put 3 in, put -1 in, -2 in, it doesn't really matter, because when you take the absolute value of it, the smallest you're going to get is 0. And that's going to happen only when x is 0. And that number is always going to be greater than -10 no matter what you put in there. So that's why it's all real numbers. But that's a special case. And a lot of people try, like I said, try to put all these 4 cases in one big lump sum and try to do them mechanical, and they get themselves in trouble when these types of problems come up. So, but that's 1.6.